Hello.
Hello.
Hi. Just a moment. Can you hear me clearly?
Yeah, I can.
Okay. Okay, I think today we are supposed to study physics. Last class, I think I was done with general physics, like the scalars and vectors and units. And today I think I'm going to talk about kinematics.
Yeah.
All right. Just a moment. Okay. So yeah. Start. With kinematics really mean kinematics? Hello?
It's about movement, right?
Sorry?
It's about movement, right?
Yeah, exactly. It's about motion. Yeah, everything in this chapter will be about, yeah, it will be about movement of an object. Okay. So basically in this chapter, I think we're going to be talking about a lot about distance, displacement. So I'm just going to repeat one thing from the last class, just so that you remember. Scalar and vector. In this chapter, you'll be dealing with distance and speed. These are scalar quantities, and displacement and velocity are vectors. Um, try to do example about speed and for example, so there is no diff for speed, velocity, right? I just show you what these are using examples. Instances like, for example, hello, did you lose me for a moment?
Yeah, actually, I can't.
Hello.
Hello?
Okay, now it should work. Let's begin again. Okay, so I was giving an example of yeah, this trajectory. So it starts from O, and then we have this turn at A, and then this is point B, this is C, and finally D. Okay, so what will be the distance here, and what will be the displacement? Hello?
Yeah, upper distance is from O to D, right? The whole thing.
Yeah, so the thing is, distance would be, you know, all the way. So O, A, B, C, D, right? Because it actually needs to go right there. So think about a car that starts traveling from here. If it goes like that and all the way, yeah, that's the distance. So O, A, B, C, D. Okay.
Mm-hmm.
Or what about displacement? Displacement is just, when you're talking about displacement, you have to think about the starting point and the ending point, not the trajectory itself. So যে রাস্তা এত টার্ন ফলো করছে, এগুলা কিচ্ছু চিন্তা করতে হবে না। মেইন কথা হচ্ছে ফাইনাল ডেস্টিনেশন কি ছিল and initial starting point কি ছিল. Basically, you only take that distance. That is the displacement. So OD is a displacement. Okay.
Yeah.
And then yeah, so like I mentioned, displacement is a vector quantity. So you cannot just say, okay, this is 500 meters. You actually need to mention the direction. So you either need to point an arrow, or you actually need to say, okay, 500 meter to the north, or 500 meter to the south, or 500 meter forward, or 500 meter backward. You actually need to mention a direction when it comes to displacement, okay? All right, next example, let's talk about, um, this is about speed. Let's think. Yeah. So I think we already know the formula of speed. Let me first give you the formula of speed, then an example maybe. So when we talk about speed, obviously it is distance traveled divided by the time taken, right? So yeah, but what if we are talking about average speed? What is the average speed?
It's the total distance by the total time taken.
Exactly. So the total distance divided by the total time taken. Now, if um if the car is like traveling through this pathway using the same speed, then obviously these two equations are the same. But yeah, if the car is traveling probably, right here it's like 5 meter per second, but then here it's 6 meter per second. So it's like probably changing, but you need to find the average speed, that you simply take the total distance divided by the total time taken. Okay.
Yeah.
All right. That means in this case, we would have put like O, A, B, C, D divided by, for example, let's say it took them 10 minutes. So you have to put like 10 times 60 seconds. Okay. Um, yeah. So you might be asked, what is the definition of velocity? Then what would you write?
It's the rate of change of displacement.
Yes, very good. Rate of change of displacement of an object. Oh, the okay. Rate of change of displacement of an object. You can just stop there, or maybe you can say from a fixed point. Okay, that's basically displacement per unit time. Okay. So if you want to write average velocity, then the resultant displacement from a fixed point divided by the total time taken. All right. So that is the average velocity. And simply write it like this: del x divided by del t. Okay. Now what is del x? Del x is basically the x final minus the x initial. X is the position. Okay. So the x is the initial, x initial is the initial displacement from the starting point, and x final is the final displacement from the starting point. Okay. I hope that's clear.
Yeah.
Okay, great. Yeah, once you're done copying, I can move on to acceleration.
It's just 1 second.
Sure.
Boom, done.
Okay, great. Now, acceleration is also a vector quantity, okay? I have to mention the direction. So moving on. So what is acceleration? Acceleration is simply the rate of change of velocity. Okay, so what does it look like? You can simply write it as v minus u divided by del t. What is v? V is the final velocity. And what is u? Is the initial velocity. And obviously del t is the time taken. Okay. Okay, now we are going to start with the graphs. There are multiple graphs that you'll be studying in this chapter. Number one graph is the distance versus time graph. Okay, so let's start with that. So obviously, like the name suggests, it shows distance on the y-axis and time on the x-axis, okay? Now, the gradient of this graph, it actually gives the speed. What is the gradient? The slope, I mean, okay? So like it should look like this. So this is, let's say, the distance in meters, for example. This is the time, which is in second. Let's say this is our straight line. So obviously the slope, oops. The slope will give you the speed. Okay. Now, the next graph that we're going to talk about is speed versus time. Okay, so oh, by the way, I'm just going to show you. Okay, next graph is speed versus time graph. Now, what does it look like? Obviously, again, speed on the y-axis, meter per second, and time on the x-axis. Okay, so let's say this is also a straight line like that. Now, this slope will actually give you the acceleration. Another thing, another information it can give you is the distance. How? The area under the graph gives you the distance. So for example, I'm just going to remove this. Let's say you want to know the distance traveled from, I'm just going to put 3 and here 4. You want to know the distance traveled from time 3 seconds to 4 seconds, okay? How are you going to find this? You can simply find this area, and this area will give you the distance that is traveled between 3 seconds and 4 seconds, okay?
Yeah.
So let's do this together. Let's say, Okay. Okay. Um, let's say we have 6 meter per second right here and 8 meter per second right there. Now let's find the distance under the graph.
It's going to be a trapezium, right?
Yes. So the distance is the area under the graph. So that is going to be half times this distance, which is 4 minus 3 times these two distances. So that is 8 plus 6. Okay, that will give you 7 meters. All right.
Yeah.
Okay. So if you have area of triangle, sorry, area of rectangle, trapezium, that's it. Okay. Next, now when you see a straight line that actually has a slope, you know that the acceleration is constant, right? So because the slope is constant of this line. What if you
Mhm.
have something like this? What does it mean?
There is no acceleration here, right?
It means that there is no acceleration. That is, the speed is not changing, speed is constant. Our graph is showing that acceleration is constant. So the speed is increasing at a steady rate. Okay.
Yeah.
These are the differences you should note. Nothing else, I think. Yeah, if you see a graph that has a negative slope like that, you know that's deceleration because it's negative acceleration. That means the speed is decreasing at a constant rate. Okay, this is negative acceleration. Constant though. Okay, all right. That was it about this graph. Now
I
the
already
next.
completed.
Okay, great. Next graph is about another sort of speed time graph where we will be showing non-uniform acceleration. As you saw here, the acceleration is constant, I mean uniform. Here is also constant. Here is no acceleration. But what happens if the acceleration is changing? Okay, we're going to see that. Okay, so let's look at the case for increasing acceleration. Okay, so what does it look like then? We have speed in meter per second. Time in seconds. Now the graph will not be a straight line anymore. It will actually look like an exponential curve. So like this. Okay. Why? Let's look at it. I already told you the slope of a speed time graph gives you an acceleration, right? So the
Mm-hmm.
slope gives you the acceleration. So if you draw a line over here and try to find the slope at this point, And then if you draw a line over here and then try to find the slope over here, you'll see that obviously the slope, the gradient is actually changing, right? So here, if you try to find the slope, it's actually less. It's less. And here the slope is higher. The gradient, in other words, will be higher on top. So that means that the gradient is increasing.
But this is because on the top there it's more steep, right?
Exactly, it's more steep. That's how you can easily recognize that, okay, the slope is increasing. That means the acceleration is increasing, okay? Okay. Now, if the acceleration is increasing, what does it mean for this speed?
The speed is also increasing.
Yes, definitely. Even when the acceleration was constant, the speed was increasing, but at a constant rate. And right now, it will increase at an increasing rate. Okay, so okay. Let's look at decreasing acceleration. Okay. Now, again, if you try to draw a slope triangle, like if you try to find the gradient over this at this point, and then if you try to find the gradient, let's say at this point, which looks like this, you'll actually find out that the slope over here is less and the slope here is higher. So that means the acceleration is actually decreasing, okay? Because the slope is also decreasing. You can easily see it with your eye, and the it's actually decreasing, and it's quite steep, okay?
Yeah.
Okay. And now what does it mean for the speed? The speed will decrease, sorry, which will increase at a decreasing rate, okay? So that's where the confusion happens for most students. The speed is still increasing because it's acceleration, but it will increase at a decreasing rate. What does it actually mean? Like the speed will increase at a decreasing rate, speed will decrease at increase at a decreasing rate. So let's say for constant speed in constant acceleration. In this case, our acceleration is 3 meters per second. meter per second square. Okay, that means the speed is increasing at a rate of 3 meter per second square, right?
Yeah.
It means, let's say if my speed is 0 at the beginning, then in just a second it's becoming 3, and then 9, and then what, 12, and so on every second. Okay,
Yeah.
in this case, let's say it is in this case, let's say when the speed will increase at an increasing rate, it acceleration. So it won't be like 0, 3, 9, 12 every second. It could be 0, 3, and then it can jump to 10, 11, and so on. Okay, it's
Yeah.
like the distance is increasing even more. Here you have a difference of what, 7. Here you have a difference of, okay, 5. I'm wrong. This is a decreasing rate. You can say here it's 20. So there's 10. It's an increasing rate. And what about decreasing? The one that I wrote just a moment ago. 10 and then 15, something like that, and then 19. So you see the speed is increasing, but the difference between them is less. Okay, that is increasing rate. Okay.
Yeah.
All right. That's it. Once you're done, let me know.
Yeah. Up and down.
Okay. Now we're going to talk about acceleration due to free fall. I think let's also talk about deceleration because it can be quite confusing. Like I showed you about deceleration. See. Okay. So for deceleration, yeah, if we draw a speed time graph, if the deceleration look like this, so a straight line. Again, if it's an increasing deceleration, then it will look like this. And then if it's a decreasing deceleration, then it will look like this. Why? Let's look at the increasing one. If you draw a triangle right here, so if you draw it right here, you'll actually see that the slope is negative, but the slope is increasing. Okay, that's why it is increasing deceleration. When I was in O levels, this used to confuse me, and that's why I'm explaining this to you. Otherwise, like maybe বইয়ে বা অন্য জায়গাতে এটা মেনশন করা থাকে না। Okay. Um, yeah, here you can check that the slope is actually decreasing. Okay, that means this one is decreasing deceleration. Okay. Okay, now let's talk about acceleration due to free fall. This is basically the G, which is the gravitational acceleration. These are the same thing. Now I checked your syllabus. You have to actually take it as a constant value of 10 meter per second square. You don't even have to take 9.81. It's okay if you write 10. Okay, that means like when an object is dropped, let's say from a top of a building, its speed will increase from 0 to 10 meter per second. Okay. All right, next, the effect of air resistance.
Apple, we just need to know the value, right, for this.
Yeah, exactly. Now, obviously, in real life, when an object is falling, let's say from a height, it will encounter air resistance. Okay, unless it's moving in vacuum. Obviously, vacuum is not like